Welcome to the Grid Mod Pod, brought to you by AEIC. In this podcast, you'll hear from the utility industry's top operations leaders on how their companies are working to modernize and improve our ever-evolving power grid. Thanks for joining us.
Hi, Melissa. So excited to have you on today. This conversation was a long time coming with our rescheduling and scheduling, but here we are to talk about something really exciting. So one thing about AEIC is we have an annual meeting, which we just had our 140th annual meeting. Think about it, listeners. Where industry leaders come together to discuss all things grid. And we're here today, we think, to talk all things grid mod. But during that annual meeting, one of our highlight events is where we announce our achievement awards, which are given to our utility members who have actively shown value in an innovative type project that has kind of transformed or drove progress in an area around embracing technology and enabling new ways of using technology to advance how we operate, perform, and ensure safe, reliable, affordable power to all. So with that, Melissa, I look forward to talking about your project, and I'll give you the table to introduce yourself and the project we're going to talk about, and we'll jump right in.
Thanks, Liz. Thanks for having me on the podcast. Yes, very excited. We finally are getting in the recording studio. My name is Melissa Peskin. I'm a consulting engineer. I've been at Dominion Energy for 19 years. I'm on the team that builds our distribution model. So we're doing a mix of engineering and IT work. And we have found it's really helpful to have our engineers doing that work, writing the code and designing the database, because it gives us a lot of flexibility and agility to fix issues that arise or add new features quickly.
Amen.
So we interact with a lot of different teams. Yeah. We work with GIS a lot. They're our main source of data. We work with ADMS. They're also building a model, the operating model. We have several user groups, multiple planning teams, protection, coordination, grid resiliency, all using the model. And then we also work with our data analytics team on projects that are data intensive, such as our Automatic Misgrids Correction project,
which is the project that won the awards. And what I heard there is that you guys have set up a very nice collaborative matrix organization to really drive value for all of the various groups that support Dominion. So that is a wonderful thing to hear. And it's actually a key part of, I think, the grid modernization is understanding the need for the collaborative de-siloing of the electric utility workspace and creating those matrix teams. So awesome to hear just on that. So I guess, you brought up, and it is what was awarded. Give us a high-level overview of what this Automatic Misgrid Correction project is and how it fits into the overall grid mod effort.
Yeah. So for every meter, we have a record of which transformer they're on. The transformer ID is based on the location on our map grid, so we call it the grid address. And a misgrid is what we call it when we have the wrong transformer association. So our electronic systems don't match the field. If a user finds a misgrid, they can investigate it using maps, satellite imagery, street view imagery is really helpful, and they can correct it, but it's hard to scale that up. So both the finding of it and, even knowing they're out there, and then also how to find the right transformer. So our Automatic Misgrid Correction project is using machine learning and some meter data to do that scaling up. So our data analytics team wrote the algorithm. We have 15-minute interval voltage from our smart meters. For every meter, they are checking the correlation with other meters. They're using the voltage, checking the correlation, other meters on the same transformer versus the voltage correlation with meters on other transformers that are within a certain geographic area. And if it finds a better correlation to a different transformer, it will flag it as a potential misgrid and propose correction. And if it meets a certain confidence level, we can send it automatically to this bot that makes the correction in the customer information platform.
So I just have to share a couple things here before we go into it. And then also I'm going to ask you a question, which if I have my avid grid mod listeners, they've probably heard the importance, but I would love it to come from an additional voice in the industry. So, I'm very close to this space because my ultimate research and my defense of my dissertation work for my doctorate was utilizing AMI voltage data to identify secondary topology. And something that I don't think the external stakeholders or even most internal stakeholders of utility understand that type of information is not available holistically across all grid owners and asset owners, operators. And that is okay because how the grid was ultimately built to serve and individual customers was that visibility was not a requirement based on the fundamentals of how the grid is constructed and then driven to serve electrons. So something we talk about here a lot, because I think that element of identifying and knowing where all assets are has just, and it continues to become a very strong focus of the grid mod space, is identifying and having full situational awareness of all assets down to the customer, back to the transformer. So here's where I'm going to throw the question over to you. From your guys' perspective, why is accurate meter transformer mapping so critical for grid reliability and the overall operational efficiencies and how we can prepare for this advanced grid that we're all talking about?
Yeah, that accurate mapping is key to operating our grid. Like you said, we don't have we think we know what transformer the meters are on, but we don't have any record of actual secondaries. So we're really relying on that relationship. When a customer calls in an outage, we use the transformer grid address to place it in our hierarchy and know where to send the truck. So if we have a misgrid, we might send the truck to the wrong place. It might make it look like there's multiple outages when there's really just one. And kind of worst case is if there's a big storm with a lot of outages, we might get one outage restored and release callbacks to those customers and mistakenly release a callback to a customer who's on a different outage. Their lights are still out. They get the call, their lights are back on. It's really frustrating. We do not want that to happen to our customers. The other thing is these errors affect our model. So anything we're doing with load planning, with finding overloaded transformers, with PER interconnections, we really want to have it, down to the customer level, have it accurate.
So, when you say it, I say it, we're like, aha, but creating the right language and bringing that awareness to the masses in regards to the extreme value that it provides. Not only is it challenging to quantify as well as qualify the value and tying it to really, dollars to do when you don't have the information to actually create that cost benefit analysis. So the more utilities that are actively deploying this type of technology in projects and then using that data to then drive the awareness is key, not only to your own performance, but to the larger industry. So if you can tell, that's why I pretty much get passionate and I'm excited to talk about this project in general. Because it seems, once you're doing it, like a no-brainer, but the amount of work and maybe the people, the processes, and the investment in the infrastructure and the knowledge and wherewithal of how to execute it takes time. So I guess, thinking through, you've been there for 19 years and you've been an active part of this member, what are some of the key takeaways from really establishing the roots to be able to develop and create this type of stuff? I would love to hear.
Yeah. So we've corrected over 7,600 misgrids. We are seeing benefits. We're upgrading our process of finding and fixing overloaded transformers right now. So starting to send out more teams for inspection. And if we find that misgrid before we say there's an overload here and we say, no, there's really not, we're saving that money on the inspection. Like you said, it's hard to quantify some of it. So we don't know for sure that lights would have gone out and we would have sent a truck to the wrong place. But any amount of customer frustration we can reduce is a big win for us and, help to our reliability numbers as well for our customers.
And so knowing that, this project itself is a current ongoing success, what role do you see, future automation and machine learning playing into really a lot of the challenges that we as operators of the grid have?
Yeah, automation is the only reason we could do this and find 7,600 of these and not spend a lot of money investigating them all. Automation lets us do what we could never do manually. We check every meter. We do that, reassociation automatically. It's just critical for scaling to our entire system. Our model has 1 million line sections, 600,000 service transformers, 2.8 million customers. So we just can't check everything individually. For us, our approach to automation is to combine it with human intelligence and employee experience. So Our data analytics team is the ones who wrote the algorithm. They're experienced in machine learning. I'm representing distribution planning from the model team. I also have worked on voltage, AMI voltage in the past. So I brought that kind of knowledge of how the voltage would behave. And then GIS was important on this team. They have the experience investigating misgrids. They know our design standards. So for example, they looked at all the data and set a guideline that if the meter and the proposed new transformer are more than 300 feet apart, it wouldn't be eligible for automatic correction. They spot checked a couple hundred of these things in the course of rolling it out. So, we work together as a team and get that confidence that this automation is working correctly and we can trust it and we can just let it run now.
So just for our listeners, I love to always kind of take us back to where we were, maybe kind of set the ground of where we are, and then kind of support a lot of, the benefits that you just described. Being able to communicate effectively these moments of aha, and then getting, or not even looking for accolades, but bringing awareness to the time it takes and the people required to really stand it up. So as I stated, there was a space when we were developing the grid where having full visibility to the edge was not a requirement because due to Ohm's law, back of the envelope calculation, you could determine at the substation breaker where the feeder leaves three-phase and then splinters off into various one-phase. And I think you said 1 million
line sections. Yep.
Line sections, which means, that's a million sections that can be reconfigured to create many more configurations, which fundamentally we can't do the back of the envelope calculations. And it was okay not to know of those configurations because it was one-way power flow, and the way we built the grid, you could analytically determine that the number of homes would not overload a certain section. But now with the ever-changing capabilities of switching devices that have automation built into them and protective devices that have automation built in them, really since the 90s and 2000s, the capabilities have been available. But now that we have AMI data that has that information and the customer becoming dynamic, you can't really fundamentally assess that million sections and all of various configurations without having computer models to support the decision making. But that doesn't mean the folks that have been operating the grid and rolling trucks for the last 40 years, if they're still employed, and some veterans that 20, 30 years, didn't utilize technology to tell them where issues were. And so there's this phenomenon, which is a culture of where you are now asking those that do not need to rely on this information to take action. And you're asking them to change their mindset to believe that these models can actually represent truth. And so what you just shared is that's 3 separate groups that you have to bring into the fold, make sure they each understand what their roles are, effectively communicate what the responsibility each now role is, and then you're going to really integrate with data, which is your team, that the GIS, the planning model team, and the field, aka Operations Center, and then dispatching of the crews, really believe in that full fleet of information being shared across, which then is the automation that we speak of. So that's why, from an achievement award, being able to set up those groups, getting the alignment across the leadership, and then driving that change is paramount and it deserves us to talk about it. So really thinking about, looking ahead, we kind of got the fundamentals. I mean, you said, at first I thought you said 7,600 misgrids, which more or less means that something that happened in the field, that information did not get communicated effectively to the GIS digital model, which again was not a requirement because of how the grid was operated years ago. But now it is a requirement because of all the dynamic change that we just took. Anyway, it's an amazing check of the box. So now looking ahead, how do you see technology and the groups that have been set up really to scale and evolve to really, enhance some of your broader goals that you have in the planning and really the enablement of all the new technologies?
Yeah, good question. Yeah. So 7,600, it's about 1/3% of all our customers, but we don't think that's all the misgrids. So we are currently working with these highest confidence. So we have the misgrid analysis tracking all of its suggestions, including the lower confidence ones. And we are adding an interface where the GIS technicians can go in and approve or reject each one. And so the approvals will go through and get corrected, but it will store all that information so that it can be training data for a future round machine. And then we're also adding an interface to let the GIS technicians submit any other misgrids that come in as red lines so that, the app is aware of all that and we don't have the app overwriting anything. So currently also the highest confidence that we're doing is single phase meters on single phase transformers. But we do have a fair amount in our dense residential areas where there's a 3-phase overhead bank serving single phase customers. So the voltage does not trend together. They're really like 3 separate transformers, but they have the same pole number. So we can't really distinguish. We don't have a record of which customer is on which transformer. And so we've talked about, could we cluster them first? Clustering analysis would make 3 groups of meters. It doesn't tell you which phase they are, unfortunately, but you could use that to then treat it like 3 separate ones and get the proper correlation. Otherwise, the misgrid analysis doesn't, really only correlates a third of the way to a good match. We're also planning a phase validation project. So that's been an interesting one. We'd like to check the phasing or use voltage and power data to correct the phasing on all of our meters, service transformers, and path lines. So yeah, just trying to get all that together. And we are also, we call it integrated distribution planning, or IDP. We want to expand our model in both time and space. So I'm very interested in what you said about secondary models, because we are talking about doing that, expanding our model in space. Right now we have primary conductor down to the service transformer, but we really do want to have some kind of secondary model. We don't have the records. It's not going to be, 100% accurate, but some kind of imputed secondary that behaves properly so that we can use that to analyze, EV charging, behind the meter solar, batteries. And then expanding in time. Currently we're focused on peak load and light load, but we need to get a better load model so we can analyze all 8760 hours in the year. So for us, IDP is those kinds of expansions. It's misgrid, it's the phase validation, which I am going to have my teammates reach out to you because this is really, I think, a good synergy there. And so, yeah, we just want to make our model more accurate and expand how we can use it.
And I guess, just to kind of summarize, and I think a lot of, once you're in it and you're like doing the work and you have the executive alignment, you have your leadership giving you the go ahead, there's a large amount of work that is required. And one area of this podcast that I want to really highlight in the continuous conversation is, understanding the idea of operational excellence. And so, that's kind of the vision of AEIC, is the thought leaders come together and talk about, kind of the people and the processes and really lessons learned. So you can build off of that information of one is information of all perspective. And so, like, if you think about the key aspects of operational excellence, it's really, how can we be more efficient and effective? How can we be aligned or customer focused? How can we be agile? So almost, fail quick, right? Like identify and be creative and safe of coming up with various ideas. And then, if they don't work, pivot and change and creating that culture really of doing so. And so I think, the project that you shared of and just knowing about, the work that would be involved to kind of get all the groups working like that is really paramount. And it highlights, what it means to be, operationally excellent, which is really a whole field of study. Driving change, getting the employee involvement, really using data to drive your decisions. That's kind of the essence of, where we are in this transformational time with the grid. So I guess, being the stewards and, in the granular details, what are some lessons learned for, any change champion in the utilities that are really maybe at the crawl state of really executing this project and getting it up and running in their own space? What'd you get?
I feel the same way as you, that it's just such an interesting time that we need to expand the model. That one-way power flow, it was good enough for that, but the model's not precise enough. I think there's both incentive and resources and a lot of value in expanding it. So I think finding the right people who want to play detective and inventor, I think it's really fun. So I think, there's probably talent in the utility who has ideas about how to work on it and is ready to, hit it. I think cross-functional teams, so bringing in engineering, design, operations, and then IT, of course. And then, I think just having all the different skills together, and especially if you have people who kind of have worked in different areas and have like a more broad experience where they can kind of help envision how the different parts can come together.
I hear it. So it's more or less, it comes down to the people and how people can effectively work together to really enable, just it's change because you're impacting multiple groups. I guess with that, anything else that you would like to share to our grid mod? And I am definitely willing to have that conversation sidebar with your team in regards to the secondary and connect you with also some other utilities that are actively working that space as well. So anything, great. Last words?
I was thinking of something else you mentioned, actually, just about what engineers do. So you might sit there and do those kind of back of the envelope impedance calculations all day long in different scenarios. And now you can make a computer do them really fast. But how do you set that up? And then what do you do with 10,000 simulation results? So I think, engineers are expanding into more of a data analysis and processing the results. And your job is, you have to understand the power engineering, but you also have to be able to interpret the results and know, how to show them and figure out, draw conclusions. So bringing in like data analysts too.
I have to say, I started my career being a power system analyst. So building models, running studies and determining, outputs, but data in, data out. So if your data isn't very great, your outputs may not be great. So there is that core function of being able to understand the phenomena of what you are studying to be able to take action. So I agree wholeheartedly. Okay, well, this was a lovely conversation, and I look forward to continue this journey with you and the folks like you at Dominion as we champion change and drive transformational projects throughout our organization.
Thanks so much, Liz. I appreciate the opportunity to talk about our project.
That's a wrap for this week's episode of the Grid Mod Pod. Thanks for tuning in. We hope today's conversation got you thinking about new and creative ways to improve our power grid. Be sure to subscribe to our YouTube channel to be the first to hear new episodes. This podcast is brought to you by AEIC, the place where operations leaders come together to share knowledge and provide guidance to the electric utility industry. We'll be back with a new episode soon. Until then, keep powering on.